Now we're going to be doing arithmetic series. A series is the sum of the sequence. So let's go back to the sequence that we had before, an arithmetic sequence 3, 6, 9, 12, 15. The series of this sequence is adding all of these numbers together. That's what a series is. A series is taking 3 plus 6 plus 9 plus 12 plus 15, adding all of the numbers in the sequence together. That's what a series is. So for this series, it would come out to be 45 of adding all these together. Okay, series is denoted by the Greek letter sigma. This letter is the Greek letter sigma, and it means sum of. So when you see this, that means you're doing a series, and it means you're doing the sum of the sequence. So there are two formulas to do a series for arithmetic series. This formula, you need to know the first term. This will be the last term. N is the number of terms in the sequence. So here you also have this formula where you have to know the first term, the number of terms in the sequence, and then also the common difference. I generally like this first formula better because I don't need to know the common difference, and so I will use this one 99% of the time. So I only use this just to prove that you will get the same answer. So it doesn't matter which formula you use, it's a personal preference. I personally like this formula better, but it's a personal preference. So again, N equals the number of the terms in the sequence. A is your first term, and A sub N is usually your last term. But looking at 26D, number 17, so when you see this symbol tells you that you're finding the series of the sequence. Series means the sum of. Like if I was to put in 1, we're going to go from 1 to 20, where x equals 1. In other words, if I put in 1 for x and get a number, then I put in from 1 to 20, 2 for x and get a number, then 3, get a number, 4, 5, 6, all the way up to 20 for x and get a number. Then I was to add all of those numbers together. That is the series. That's the answer for the series. So the series is the sum of a sequence, but instead of finding all of those numbers, we can use the nifty formula. Okay, so we're going to be using this formula where N, that's the number of terms. I need to know the first term plus whatever the last term is divided by 2. Okay, so to plug into my formula, I need to know the number of terms. Well, N, the number of terms in this series, from 1 to 20, if I go from 1 to 20, I will end up having 20 different numbers. So the number of terms in that sequence will be 20. My first term, to get my first term, you take whatever this first number is and plug it in for x. So now I'm going to plug in 1 for x. So take 3/2 times 1 plus 1. Okay, so basically 3/2, because that's already 3/2 plus 1. I can change this into 2 over 2 to make a common denominator. So A sub 1 equals 5 over 2. Okay, I need to know my last term, or the nth term, which will generally be whatever this number is, because that will be the last term. So I need to know A sub n, which in this case would be A sub 20. So putting in 20 for x right here. So 3 over 2 times 20 plus 1. So that's going to be 3 times 20, 60 over 2 plus 1. 60, I could have just canceled those out right there, but okay. 60 divided by 2, 30 plus 1. So my last term is 31. Okay, so let's plug in now into our formula. Okay, here's our formula, and this is going to give us the series. Instead of putting 1 in, now plugging 2 in, 3 in, 4 in, and then adding all those together, all we have to do is find two different numbers and know the number of terms and put it into your formula. Okay, so the number of terms is 20. My first term is 5/2 plus my last term is 31 all over 2. Okay, so I'm going to go ahead and add these numbers in the parentheses first. So this we need to make a common denominator there. So, and that will be 25 over 2 plus this to make a common denominator. both of these need to be multiplied by 2 over 2. So then this would be 62 over 2, all over 2. I need to go to the side. Adding what's in parentheses, that will be 20 times 5 plus 62 would be 67 over 2, all over 2. I can cancel this 2 with that, and that will become a 10. And then 10 times 67, 670 divided by 2. And sometimes these won't work out to nice neat whole numbers, sometimes they'll end up with a fraction, and that's okay. And that will come out to 335. So the series for this problem is 335. If I was to do all 20 terms, the first term, second term, third term, then add them all together, it would add up to 335. Okay, we're doing 26b 18. We want to do the series from k equals -3 to 8 of 5/8 k. So we need to know how many terms are in the series first. We're going to use this formula. So I need to know the number of terms, I need to know the first term, and I need to know the last term. So the number of terms. So be careful when this is not a 1, okay? So you have to think of a number line. If you have 0 all the way to 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3. Okay, if you're going to go from -3 to 8, you have to be careful because you have to count 0 in there as well. Because you're going to be plugging in -3 for k, then -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So if you were going from 1 to 8, that would be 8 numbers. Okay? And then from -3 to 0 is 4 numbers. So just be careful when you are counting. You can't just like add these together or subtract these, okay? Because you have to include 0 in there. So for this case, the number of terms is going to be 12. Okay, now we need to know what the first term is. So the first term comes from plugging this first number into k. So my first number that I'm going to plug in is, my first number for my first term is plugging in -3. So 5/8 times -3. That'd be over 1. So that would be -15/8. That doesn't reduce. Always reduce if you can. Okay. My last term comes from plugging in this last number. So my last number is, I'm going to plug in 8. So that would be 5/8 times 8. And that 8 will cancel and you're left with 5. So my last term is going to be 5. So, okay, now I can put all this into the formula. Okay, so my number of terms is 12. My first term, -15 over 8, plus my last term, 5. My last term came from plugging this number in. Okay, all over 2. Well, I'm going to have to make a common denominator. So this needs to be multiplied by 8. So then I have 12 times -15 over 8 plus 40 over 8 all over 2. Add my fractions on the inside. -15 plus 40, 25, 35, 40, 25 over 8. That doesn't reduce. All over 2. I can reduce this 8 and 12. So reducing that by 4, that becomes a 2, that becomes a 3. So then at the top I have 75 over 2, all over 2, that's 2 over 1. Fraction divided by a fraction, flip the second one and multiply. So that now becomes times 1/2. So then you end up with 75/4. So if I was to take each one of these numbers and plug them in for k, get a number for each one, then add them all together, you end up with 75/4. That is the series for this one.